Hi, boys and girls. Welcome to Volume 2. We made it. Last year, I don't think we even made it into Volume 2. Last year was a weird year, kind of ended strangely and suddenly. But yeah, so this is Volume 2. And what a beast. 7-1 is humongous. So I have gone through and tried to pre-fill out some stuff. I've pre-graphed some stuff on Desmos to try to save time so that this video is not humongously long. Okay, so let's get started. In your workbooks on page 387, 387, is that right? Seriously? 387? I guess it doesn't start over again with 1, does it? Okay, here are some terms you're going to learn. We're going to be solving systems of equations. That means we're going to have two linear equations. If there is a solution, the solution is where the two linear equations cross. Okay, so you could imagine that if you had two lines going in different directions, at some point they will intersect. Okay, that is the point, the xy coordinate, that solves both of those lines. It works both equations. But sometimes you have oddities. Okay, and so that's why we have all these different things. The word consistent means that a system of equations has one or more solutions, but at least one. Inconsistent means there is no solution, okay? And what happens is if you have parallel lines, they never intersect. So there is no point that solves both of them, okay? So that's a no solution situation. Independent means it has exactly one solution. Remember, consistent meant you could have one or more. Independent means one. So remember, if you're independent, you do everything by yourself, one person, okay? Dependent is sometimes you'll have two equations. Maybe they're not in slope-intercept form and you can't tell right away, but they actually are the exact same line. And that's an infinite solution system, and that's considered dependent. Okay? Let's see. Here we have an example 1. This is a consistent system because there is one solution. It's this little point here. 1, -2 solves both equations. Okay, so this has one solution. All right, so here are the two equations. If you plug the point 1, -2 into this one, it would give you a true statement. And if you plugged 1, -2 into this one, it would also give you a true statement. That point solves them both. Okay, so it wants to know, is this consistent or inconsistent? Remember, consistent means one or more solutions. It has one solution, so it's consistent. Independent and dependent. Independent is one solution, dependent is infinite solutions. This is independent because it has one solution. All right, example 2, we have parallel lines, okay? This is considered it's considered inconsistent, all right? Because there is no solution. They will never meet, okay? It's inconsistent. And how do you know looking at these equations? Well, here's how you know. If the slopes are the same, but the y-intercepts are different, that means you have parallel lines. Anytime you have two slopes that are identical and y-intercepts are different, then you're going to have parallel lines. Okay, so here we have this first system here. Is it consistent or inconsistent? All right, is there one or more solution? Not to this one. This one is an inconsistent, okay, because there's no solution. And these are not dependent or independent, okay? Remember, independent is one solution and dependent is infinite solutions. But there is not a dent word for no solutions, okay? Now this one has one solution, so it's considered consistent. And because it's only one solution, it's independent. We reserve the word dependent for two lines that are the exact same line. These, not the case. Okay, number of solutions, equations in slope-intercept form. It's pretty easy to tell how many solutions it's going to have if they're both in slope-intercept form. All right, here they've given you two equations. You will notice that the slopes are identical, but the y-intercepts are different. Okay, because the slopes are the same and the y-intercepts are different, the lines are parallel. This system has no solution, therefore it's considered inconsistent. Okay, time savers. That's what I'm talking about. Determine the number of solutions. All right, well, they did us a solid on this first one because they wrote it in slope-intercept form, but unfortunately, this guy is in standard form. So we're going to need to change that to slope-intercept form so we can make a decent comparison. We have 4y minus 5x equals 9, okay? We want to get y by itself on the left, so let's go after this 5x and get rid of that. Add 5x to both sides. That gives me 4y equals 5x plus 9. Now we need to divide every term by 4. Okay? And that gives us y is equal to 5/4 x plus 9/4, which I guess we could write as 2 1/4. Okay? So this does have the same slope. Oh, no, I'm comparing it. Okay, we're going to compare it to this one here. All right. This one has a slope of 5/4. This one has a slope of 4/5. All right. This is positive. This is positive. Now, if they were negative reciprocals of each other, they would have been perpendicular, but they're not. They don't have the same slope. They don't have the same y-intercept, which means they will have exactly one solution. There will be one point that solves both of them. Okay. All right, example 4, number of solutions, equations in standard form. Okay, so if they give it to you in standard form, you have to fix it, okay? So that's what I've done here, and I've gone ahead and filled all this out in advance to save time. We have 2 equations in standard form. They took the first one here, and they're trying to get y by itself, so they add 6 to both sides. Then we have 4y equals 6x plus 16. They divided everything by 4, which ends up giving us y equals 3/2 x plus 4. Over here, we got rid of the 9x by subtracting 9x from both sides. Then we divided everything by -6, and we end up with 3/2 x plus 4. Notice that these 2 equations are identical, okay? They are the same line. Because the slopes are the same and the y-intercepts are the same, this is the same line. If you graph these, you would graph one right on top of the other one. Because the graphs of these 2 lines are the same, there are infinitely many solutions. Therefore, the system is now consistent, has one or more solutions. It definitely has more than one, but it's consistent. And dependent, because dependent is the word that means they are the same line. Okay. All right, determine the number of solutions for this system. We're going to have to put them both in slope-intercept form, which is my favorite thing to do, math. Alrighty, let's have some fun with this. We'll start with 4x minus 8y equals 16. We want to get rid of the x because it's not supposed to be on the side. So subtract 4x from both sides gives me negative 8y equals negative 4x plus 16. And then divide everything by negative 8. Negative 8, negative 8, which gives us y equals positive 1/2 x minus 2. All right, 4 over 8 reduces to 1/2. Negative over negative is a positive, and 16 divided by negative 8 is negative 2. The other equation, 6x minus 12y equals 5. Get rid of the 6x by subtracting 6x from both sides. That gives me negative 12y equals negative 6x plus 5. Okay. Divide everything by negative 12. And we get y is equal to 6 over 12 reduces to 1/2 x. And this over here, this would be 5/12, negative 5/12, and that does not reduce. Okay, so roughly 1/2, but still, we have slopes that are identical, but y-intercepts are different. So these 2 lines are parallel, right? They're parallel because they have the same slope and different y-intercepts, so they will have no solutions. I guess put 0, none, whatever, no solutions. Okay. Now, another thing you can do is you can take equations and you can graph them, and then you can find, why is my picture flicking in and out? you can graph them. And weird. And then with the point where they intersect is the solution of the system. So if you were to graph two lines and find that they intersect at negative 1, 3, negative 1, 3 is the solution to the system of equations. All right, so they're going to ask us to solve this by graphing these two lines. Okay, I'm tired of this color. I want a better color. Let's go with red. Okay. All right, so the first one has a y-intercept of positive 14, so we put our dot there, and a slope of negative 2, which means we're going to go down 2, right 1. Okay, but we got to keep in mind here, these are numbered every 2. So down 2 would be here, right 1 would be here. And then down 2, right 1 would be here. Down 2, right 1 would be here. And when you're trying to find the intersecting point, oftentimes it's helpful to put multiple points because sometimes you get lucky and your point of intersection is one you've graphed. Okay, so I'm going to keep going. Down 2, right 1. Down 2, right 1. Down 2, right 1. Down 2, right 1. All right, we'll go with that one for that one. The other equation I'm going to graph in a different color. Notice I'm not drawing the lines quite yet. You don't really need the lines to find the point of intersection if they happen to be the same point. This one is got a y-intercept of positive 1, okay, and a slope of 3/5. So that means we go up 3, right 5. So we would go up 3, right 5, boom, shakalaka. That's exactly why I did that too. Now we know that this is the point of intersection because this line is going to go like this. And this line is going to go like this, and that is our point of intersection right there, which is the solution. Let's see, what is it? It's 5, 4. 5, 4. Oh, I guess we'll just put it down here. Appears to intersect at the point 5, 4. And if you substitute 5 and 4 into for x and y, both are true. Therefore, 5, 4 is the solution. And that's how the system of equations are. You will have an xy point that is the solution to those two equations. It's the x and y value that solves both of them. Okay, graph the system of equations. And of course, they're not in slope-intercept form. See, I told you this. And you know what? There are 10 examples in this section. That's why I tried to shorten it as much as possible. I all out now am going to skip one of the word problems because it's absolutely ridiculous. All right, so 3x plus 5y equals 10. I want y by itself, so I subtract 3x from both sides. That gives me 5y equals negative 3x plus 10. Divide everything by 5. And this equation is y equals negative 3/5 x plus 2. So hang on a second. Let me pause it. Sorry, interruptions. Okay, so we were going to start graphing at positive 2. Okay, and this would be positive 2 right here, positive 2, and we have a slope of negative 3/5, which means down 3 and then right 5. So it'd be 2, 4, 5. Ooh, I don't like that. And then we would go down 3, which would be here, and right 5, which would put us here. Oh boy. I could go up 3, left 5. It would be up 3, left. Oh, it's another one of those. And up 3, left 5, puts us here. So that's the first line. Okay, second line, let's do it in red just for fun. The second line is y minus 5y equals negative 10. Subtracting x from both sides gives us negative 5y equals negative x minus 10. And divide every single term by negative 5. And that gives us y equals 1/5 x plus 2. Let me explain how I got that. There's an imaginary 1 here. A negative divided by a negative is a positive. So we have 1/5 for our slope. And then negative 10 divided by negative 2 or negative 5 is positive 2. So our y-intercept is positive 2. Oh, boom. Check it out. I know what point solves them both. And the slope is positive 1/5. So we would go up 1, right 5. Or we could go down 1, left 5. But either way you slice it, the point of intersection is right there at 0, 2. The point where the two lines intersect. Okay, don't make fun of my lines. I know you're laughing. You should try it on this graphic tablet. This thing is really hard to draw on. Okay, moving on. So now they've given us two equations that have not in slope-intercept form. Oh, and once I get to this next section, you're going to be going, Miss Williamson, why did you waste all of our time on those? Negative 3x plus 2y equals 12. All right, add 3x to both sides. I don't know why they don't just give them to us in slope-intercept form. 2y equals 3x plus 12. Divide everything by 2. It gives me y equals 3/2 x plus 6. Slope-intercept, y-intercept is 6, and the slope is 3/2, so we could go, let's see, doing it every 2 again. So up 3, right 2, or we could go down 3, left 2. Let's go down 3, left 2 again, just so I can have a nice line for this one. It's so hard to draw a straight line. Okay, now let's switch over to blue. Okay, and we'll solve the other one. I'm going to subtract 6x from both sides. That gives me negative 4y equals negative 6x plus 8. Divide everything by negative 4. That gives me y equals negative over negative is a positive, and that fraction reduces to 3/2 x, and this would be minus 2. Okay. Uh-oh, I see what's going on here. This one has a y-intercept of minus 2, but it has the exact same slope. So up 3, right 2, up 3, right 2, up 3, right 2, up 3, right 2. You see what's going on here? These lines are parallel. The lines have the same slope but different y-intercepts, so the lines are parallel. Since they do not intersect, this system has no solution. There is no xy point that will solve both of these equations, ever. Okay, and this was the example where I finally just said, you know what, we're not doing these word problems, because this thing turned out to be a nightmare, okay? This one's, you know, and it's not so much coming up with the equation that was impossible, but it's their graph. I hate their graph. It says China and India are the two most populous countries in the world. The populations of these countries have increased steadily in recent years. In 2010, China and India had populations of about 1.34 billion and 1.19 billion, respectively. I hate when they do that. Then you got to figure out, okay, they said China first, so China's the 1.34. All right. By 2016, the populations grew to about 1.38 billion in China and 1.29 billion in India. Predict the approximate year when the populations of the two countries will be the same. They want you to write linear equations that represent the growth of both China and India, which that is legit. Okay, I get that. All right. China, now we got to think about this. How many people did they gain from 2010 to 2016? They gained 0.04. 0.04 billion people in over a period of 6 years. Okay, 10 to 16 to 6 years. All right, then we go to India. All right, what rate are they gaining people? Well, they gained 0.1 peoples in 6 years. Okay, well, you're not supposed to have decimals and fractions. So you have to multiply top and bottom here by 100 to get rid of this decimal, which then gives us 4 over 600. And reducing this, we get 1 over 150. This is the rate of change of the population of China, okay? India, we just have to multiply top and bottom by 10, and we get 1 over 60. So this is the rate of change of the population of India. What would be the equation then? Well, China, our rate of change is 1 over 150, x. And then where's the starting point? Well, we're starting in 2016 here. So our starting point is 1.38 billion. That's our equation for China. Our equation for India is 1 over 60 x, and their starting point is 1.29. And then they want you to graph those on this janky, messed up graph. Okay, well, first of all, I can find the y-intercept. It's like right here, right? For the first one, 1.38, it's like right there. But how do you use this slope to find another point? This, according to this slope, I would have to go up 1 billion people. The graph's not even big enough to go up 1 billion people, and write 150 years. It's not even on the stupid graph, okay? So then I'm going, all right. In a future problem, they have you go to Desmos, okay? And I said to myself, let's do this on Desmos. So here's what I'm going to show you. First, I'm going to pause the video, and then when I pop back up, we'll be on Desmos. It's going to be super fast. So here's the graph of China and India's population growth. All right. Yes, there are two lines here. You can just barely see. There's a pink one and a blue one. Okay. And where do they intersect? It looks like somewhere in here. Let's zoom in. Okay. And see what we can find. Okay. You know what? I see a point of intersection right here. They intersect at the point 9, 1.44. Okay. 9, 1.44. So now we go back to this. And what they come up with is that they intersect at 9 here is what they end up saying. It's like at 9, it puts us somewhere like right here, okay? Well, what year would the populations be the same? You have to add 9 to 2016, and you get 2025, which is the answer that they ultimately give here. Okay, then I got to this problem and I realized this is just a repeat of the China debacle. And I'm like, we don't have time for that. This video is already at 22 minutes and there's 10 examples. Forget the Olympics, forget China. Moving on. Using systems to solve linear equations. Another huge waste of your time. Okay, use a system to solve a linear equation. I look at this and I go, why? This equation has one variable, and I can actually solve this in my head. If I was going to do this in my head, wouldn't you subtract 8 from both sides? That would give you negative 6x equals negative 12. Divide both sides by negative 6, x is 2. I could solve it like that. No, they have to complicate it. In this section, here's what they want you to do. They want you to write an equation. Oh, I need the pen. Need the righty thing. Okay. They want you to write an equation by taking a y equals and a y equals. And then you put this side of it in one of them, negative 6x plus 8. And this side of it in the other one, negative 4. And they want you to graph them, find the point of intersection, and then use the x coordinate as the solution. You're going to love this. Hang on a sec. So here we have in Desmos, I put the two equations in, and we find the point of intersection, which is right here. Why is it not popping up? Right there, 2, negative 4. And the x coordinate is 2. That's the solution. And there we have it. Oh, the solution is 2. Duh. We knew the solution was 2. We didn't have to do all this to get 2. Oh, and they're all, check your solution. Put 2 in for x. That gives you negative 12, which gives you negative 4, which means it's true. So 2 is right. Whatever. Okay, reveal. That's all. Use a system of equations and your graphing calculator to solve. Well, see, now here's where they tip me off on the graphing calculator. Because, first of all, you know I don't like decimals. I love fractions, but I hate decimals. And so here they give us this big old ugly problem. What you would do is you would say y equals this side and y equals that side. And then you would graph them in a graphing calculator, which is what I've done. So here we have Desmos. I graphed both of these equations, and the solution is, okay, so it looks like the x coordinate is negative 2.133. Negative 2.133. Yep, they want you to round that. Okay, so we go back over here, and they want it rounded to the nearest hundredth, 2.13. Was it negative? I can't remember if it was negative. No, yeah, it's negative. Negative 2.13. So that's what we would put in the little box here. Negative 2.13. That's it rounded. A lot of work, huh? It would be so much easier to just solve this for x. Yeah, I'm not going to focus on these kind of problems in this section. No, not. Okay, so now they're really hitting hard on the Desmos, okay? They say, first of all, you have to write it in slope-intercept form, then graph it, then find the intersection. But they're wrong, because Desmos doesn't care if it's in slope-intercept form. Desmos can graph it if it's not in slope-intercept form. So see, they've given you these two equations that are in standard form, and they go through all this rigmarole here to get them into slope-intercept form. And watch it. Desmos doesn't care if they're in slope-intercept form. So you don't care. I just typed them in the way they were in the book. Look at right there, not even in slope-intercept form. Complete standard form. Desmos figured it out. Here's the point of intersection, negative 5.542. It would be the solution because you're looking for the x-coordinate. That's the one that solves the equation. And we go back here, and there we have it, negative 5.54. They rounded it. That's your answer, okay? Or that's your solution. This is the point where they intersect, rounded to the nearest hundredth. You didn't have to put them in slope-intercept form for Desmos to do that. And you have access to Desmos in class and on the air test. All right, so here we have another one, 2.29x. They want you to go all the trouble putting these in slope-intercept form, but guess what? Totally unnecessary. Here we have, I put them in just the way they gave them to us. I go to the point of intersection. I write that down, round them to the nearest hundredth, and bam, I've got a solution. All right, example 10, another word problem. I'm only doing this because I want you to know how to put this into an equation, okay? Denzel is starting a food truck business to sell gourmet grilled cheese sandwiches. He has spent $34,000 on the truck, equipment, permits, and other startup costs. Each sandwich costs about $1.32 to make, and he sells them for $7. How many sandwiches does Denzel need to sell to start earning a profit? Okay, so they're saying let X equal the number of grilled cheese sandwiches he sells. Let Y equal the total cost. So you're going to have two equations here. You've got the total cost equation where you have Y equals 1.32. That's how much it costs to make each sandwich. X is the number of sandwiches plus the it should have been 34,000. Oops. That should be 34,000. Missing a zero. Now it doesn't fit. Of course. Okay. Plus the 34,000 it cost him to buy the truck and all the stuff. You also have a total revenue. This revenue is like the money he's making, okay? And your revenue equation, the money he makes is equal to $7 times the number of sandwiches he sells. So this is where you get the two equations, okay? Then you would go over to Desmos and you would graph the two equations and you would find the point of intersection, okay? The point of intersection is right here, all right? Well, it wants to know how many sandwiches he will have to sell. Remember, X represents the number of sandwiches, okay? So in this equation, the number of sandwiches is the X coordinate, and they've rounded it, obviously 0.9 rounds quite easily to another sandwich. So once he sells 5,986 sandwiches, he will begin to earn a profit, okay? That brings us to the end of a rather long video, okay? And the answer to the secret question is Army. You know, like Army Navy or Army Ants. The secret word is Army. You will need to remember that. All right, I am not going to waste any more time. I am signing off of here. I hope you've enjoyed this wonderfully long and detailed video, and I will see you in class.